Hello everyone, welcome back to the channel Learning Lane. In this video, what are clouds? Types, formation, and role in weather is explained. Clouds, those white, fluffy formations in the sky, are more than just scenic backdrops. They play a vital role in weather, climate, and the Earth's water cycle. In this video, we'll explore clouds from a geographical perspective, designed specifically for degree-level students. Introduction to clouds. Let's begin with the basics. A cloud is a visible mass of condensed water vapor or ice crystals suspended in the atmosphere. It forms when moist, warm air rises, cools, and reaches its dew point, causing water vapor to condense around tiny dust, pollen, or salt particles called condensation nuclei. Conditions required for cloud formation. Cloud formation depends on three main conditions. Let's break them down one by one. 1. Moisture means water vapor in the air. The atmosphere must contain sufficient water vapor, which is simply water in its gaseous form. This moisture usually enters the air through evaporation from oceans, lakes, rivers, and even plants through transpiration. The higher the humidity, the greater the potential for cloud formation. But water vapor alone isn't enough, it needs help to condense. Next is cooling mechanism, which means dropping air temperature. For clouds to form, the moist air must cool to its dew point, the temperature at which air becomes saturated, and condensation begins. This cooling can happen in several ways. Convection, when warm air rises and cools as it gains altitude. Frontal lifting, when a warm air mass is forced upward over a cold one at a weather front. Orographic lifting, when air is pushed upward by terrain like mountains. Radiational cooling at night, the ground loses heat and cools the air above it. Once the air cools enough, it can no longer hold all its moisture as vapor, so the water starts to condense. 3. Condensation nuclei, it is surfaces for condensation. Even with moisture and cooling, clouds won't form unless there are tiny particles in the air for the water vapor to cling to. These are called condensation nuclei. They include dust, pollen, sea salt, ash, and even pollutants. These microscopic particles provide the surface needed for condensation to begin. Without them, water vapor would remain in the air and clouds wouldn't form. So remember, to form a cloud, the atmosphere needs three key ingredients: moisture, cooling, and condensation nuclei. Without any one of these, cloud formation simply can't happen. Next, we will see classification of clouds. Clouds are classified primarily based on two key factors: altitude, that is, how high they form in the atmosphere, and their appearance, or shape and structure. 1. High-level clouds above 6,000 meters to 20,000 feet. High clouds form in the upper troposphere, where temperatures are very low. They're composed mostly of ice crystals, not liquid water. Cirrus, thin, wispy strands that look like white feathers. They often appear during fair weather but can also signal a change in the weather, particularly the approach of a warm front. Cirrostratus. These are thin, sheet-like clouds that cover much of the sky and often produce halos around the sun or moon. Their presence often indicates precipitation is on the way. Cirrocumulus, small white patches or ripples that give the sky a mackerel appearance, a term used because it resembles fish scales. These clouds are often seen in rows. 2. Mid-level clouds, 2,000 to 6,000 meters, 6,500 to 20,000 feet. These clouds contain water droplets and sometimes ice crystals if temperatures are low. Altostratus. These are gray or blue-gray clouds that usually cover the entire sky. They're often associated with steady precipitation, either rain or snow, though they don't usually produce it themselves. Altocumulus. These are white or gray patches of clouds, often in wave-like or parallel bands. They may indicate instability in the mid-atmosphere and sometimes precede thunderstorms. 3. Low-level clouds below 2,000 meters to 6,500 feet. These clouds form near the Earth's surface and are made primarily of liquid water droplets. Stratus. Uniform, gray layers that cover the entire sky like a blanket. They resemble fog but are not in contact with the ground. Stratus clouds often bring drizzle or light rain. Stratocumulus. Large, lumpy, rounded cloud masses, usually gray or white. They may cover the whole sky or appear as broken patches. These are Non-rain producing clouds, though light precipitation is possible. Nimbostratus, thick dark gray clouds that cover the sky and produce continuous, steady precipitation. Nimbo means rain, and stratus refers to their layered structure. For vertically developed clouds, these clouds are unique because they span multiple altitudes from low levels to the upper troposphere, cumulus. These are the classic fair weather clouds, white, fluffy, and cotton-like. They form due to convection, where warm air rises and cools. While generally harmless, they can grow vertically into storm clouds. Cumulonimbus clouds produce thunderstorms, heavy rain, lightning, hail, and even tornadoes. Their presence signals severe weather. Here is a diagram illustrating the classification of clouds by altitude and appearance. It shows the four main altitude levels: high level, mid level, low level, and vertically developed, along with specific cloud types and their approximate positions in the atmosphere. 4. Role of clouds in weather and climate. Clouds are not just passive players floating across the sky, they're active agents in shaping both daily weather and long-term climate. Let's look at three major roles that clouds play. Regulating temperature. During the day, clouds act like a giant sunshade for the Earth. They reflect a portion of incoming solar radiation. Sunlight back into space. This process is called albedo. At night, clouds act more like a blanket. They trap the Earth's outgoing infrared radiation, reducing heat loss and keeping the surface warmer. This is why clear nights often feel colder than cloudy ones. Producing precipitation. Almost all forms of precipitation begin in clouds. Depending on temperature and atmospheric conditions, this precipitation may be rain, snow, sleet, or hail. Cloud types like nimbostratus and cumulonimbus are particularly known for producing significant precipitation. Next, we'll see storm formation and weather events. Some clouds are strong indicators of severe weather. Cumulonimbus clouds, for instance, can grow vertically up to the stratosphere, forming thunderstorms. These clouds produce lightning, thunder, heavy rain, hail, strong winds, and even tornadoes. They are also associated with cyclonic systems, such as tropical storms and hurricanes. So when we see a dark, towering cumulonimbus cloud, we're looking at a powerful weather engine in action. Clouds are central to the Earth's climate system. They regulate temperature, produce precipitation, and drive storm activity. Without them, the planet would experience extreme temperatures, disrupted water cycles, and far less atmospheric balance. 5. Cloud observation and remote sensing. Clouds are monitored using satellites. Radar and weather balloons. Satellite imagery shows cloud movement and patterns. Weather radars track rain-producing clouds. Ceilometers and LIDAR are used to measure cloud height. Understanding cloud behavior helps meteorologists forecast weather more accurately. 6. Special cloud types and phenomena. Here are a few special cloud types and phenomena you should know. Lenticular clouds, lens-shaped, form over mountains. Mammatus clouds, pouch-like, often follow thunderstorms. Noctilucent clouds seen during twilight, extremely high altitude. Contrails, artificial clouds formed by aircraft. 7. Importance of clouds in geography. In geography, clouds help us to understand climate zones. Cloud types and frequency vary by region. Predict weather patterns by analyzing cloud development and movement. Study the water cycle. Clouds are critical in the process of evaporation, condensation, and precipitation. Let's recap everything we've learned about clouds. Clouds form due to condensation of moist air. They are classified by altitude and shape. They influence weather, climate, and the hydrological cycle. Observation through modern tools helps improve weather predictions. Next time you look up at the sky, remember clouds are not just beautiful sights, but complex, dynamic systems that impact our daily lives. If you found this video helpful, like, share, and subscribe for more geography content, and don't forget to leave your questions in the comments below. Thanks for watching.